Hello! Last year I made a video in which I demonstrated how a car stereo system works. I made a teardown, took a closer look at the overall principle of operation, and hacked the system in order to connect MP3 players or smartphones to it. Just a couple of weeks ago, I also added a Bluetooth receiver to that stereo. I recommend you to watch both those videos if you are interested in this topic. Links can be found in the video description of this episode. In the comment section of the Bluetooth hack video, one viewer also asked me if it would be possible to build a stationary home stereo system from an old car stereo like this. In fact, I liked that idea very much, since I was thinking about doing that for many years. And as luck would have it, I now got my hands on two old car stereos for free, and in this episode I will use one of them to build a home stereo system. The first one is a Philips 22RC229/80. It has a radio receiver for FM and AM radio, as well as a cassette drive. And as far as I can say, it does not have an auxiliary input or line in. The second one is an ICES 1394 Jamaica. It already comes with a CD drive and also has a synthesizer tuner. I also have a fitting connector with two RCA jacks, which could be used to connect various sound sources directly to it. A nameplate on top also tells us the pin out of the connector on the back panel. I connected the stereo to a LED power supply, but couldn't get it running. It also has several other damaged parts, and I don't have the time to make a repair right now. Therefore, we will leave this unit aside and make a stereo system based on the Philips branded unit instead. It is the more primitive of the two, but on the other hand it is also of better build quality, and the fact that it doesn't have a line in makes it more interesting to hack anyways. First I remove the cassette drive because it obscures the view at the PCB sitting beneath it. But even now we can only see a few components, namely electrolytic capacitors, some diodes and other miscellaneous through-hole components. The total lack of integrated circuits tells us that this is a double-sided board with all control circuitry sitting on the bottom side of the board. Other than in the Blaupunkt stereo I worked on in the aforementioned videos, the RF circuitry is entirely encapsulated in a metal can right here. Even though this stereo would roughly be from the same era as the Blaupunkt unit, a very different layout was chosen here. In order to test if the stereo is even operational, it is first necessary to find out the pin out of the connectors on the back side. This is something that every one of you will have to do if there is no information on the enclosure of the device. After using the model number for a short online search, I found this overview, which gives you an abundance of information about the pin out of several different types of car stereos. First, you have to narrow down the information that is given to you according to your specific model. Here we have all the information that we need. After connecting clamps to ground and the two pins requiring plus 12 volts, and hooking them up to a DC LED power supply, I check if the stereo turns on. And indeed, the cassette drive starts spinning as soon as a cassette is pushed inside. A faint reading can be seen on the LCD, yet it seems clear that the backlight of the display is broken and will have to be repaired later in the process. But before I go any further, I connect a loudspeaker to the pins to find out if the pinout is correct and if the amplifiers are working. The next thing I do is to solder wires to the pins of the power supply and the loudspeakers. I use salvaged wires from ordinary power cords, as I do in basically all of my projects. Since the pins are sitting close together, heat shrink is also used to prohibit short circuits that could occur while bending the wires during the installation process. Before I will start to hack the stereo system, I will have to fix the backlight. The filament of this old-fashioned light bulb is burned out. I cut it out and replace it with a white LED plus series resistor, and again heat shrink is applied. Now we get a clear reading from the LCD again. After I had reinstalled the cassette drive to test the system, it is being removed again. And this time it will be gone for good. It will be replaced by a line in and a Bluetooth receiver. Let's not kid ourselves. Nobody uses cassettes in the 21st century anymore. But before we can throw it away, we have to find the pin out of its connector. It turns out that we have simply one switch that connects the yellow wire to either the blue or the red one. In radio mode, yellow and blue are connected, while a cassette being pushed in connects yellow to red. We will later install a switch on the front panel to do this job. The other three wires are signal ground and the two signal lines from the magnetic reader head. Okay, so with the cassette drive removed, it is now time to talk about the different possibilities to connect an external sound source to a car stereo without a line in. In my aforementioned video about the car stereo hack, I already took a closer look at the circuits inside a typical car stereo system. This time, I will break it down to only the most important functional blocks representing a lowest common denominator for a variety of car stereos that people can get for very little money. You will often have a cassette drive with a magnetic reader head that actually consists of two separate coils that induce alternating voltages when a magnetic tape is moved across their surface. They basically act as two independent voltage sources which deliver a very small voltage. In order to connect the reader heads to the power amplifiers of the stereo system, a set of preamplifiers is needed. These are most of the time simple operational amplifiers which set the signal to a level of around several hundred millivolts or more. From here, the signal is directed to some kind of audio controller which allows to adjust the volume and other properties of the output signal. After that, you will find power amplifiers for each independent channel, which in turn drive the loudspeakers. By removing the cassette drive, the inputs of the preamplifiers are theoretically free to receive a signal from just any other voltage source. It might seem as a very abstract concept, but on this level, a computer, MP3 player, smartphone or a Bluetooth receiver simply acts as a voltage source. These sources, however, are too powerful to be connected to the preamplifier's inputs directly. Therefore, I will add a small board with adjustable voltage dividers to step down the signal to an acceptable level. The values for these resistors shown here are experimental and are also determined by what I happen to have lying around in the lab. Should the sound quality prove to be very poor, I will then go for another approach and completely remove the preamplifiers from the PCB. Another board with a very different voltage divider will then be added to the stereo system instead. And under optimal circumstances, no voltage divider will be necessary at all. The first attempt, in which I will keep the preamplifiers running, will deliver a lower sound quality. But it is also much easier to apply, since no modifications of the original PCB are required. This might be of interest for some of the less experienced viewers. And that's why I want to show both possibilities. So what I do now is to remove the connector, including some remaining wire from the cassette drive. I then apply some solder to the tips of those wires, make a small Vero board with the adjustable voltage dividers and install the board on one of the old mounting posts of the cassette drive. I then connect all the wires and add an RCA audio cable in order to connect the stereo to any given source. But before I can test if it all works and if the sound quality is acceptable, I will first have to make a set of loudspeaker boxes for our little home stereo system. For that I will reuse the old loudspeakers of this broken TV set, which I also got for free. TV sets like this one, even in working condition, have totally lost their value. You can get them for free on every corner, at least here in Germany. It's a good source for parts. But we will have to talk about the other stuff that you can find in here in another video one day. For now, we are only interested in these loudspeakers. They are 8 ohms speakers, which is less than ideal for a car stereo system. Since car stereos run on only 12 volts, you usually use loudspeakers with a lower resistance value in order to achieve more output power. But here at my channel, we work with what we have, and these loudspeakers will suffice for our purposes. Furthermore, we will use these wooden boxes here, which I picked up from the trash years ago. I always knew I would use them one day. In order to mount the speakers to the boxes, I cut out some wooden front panels with my jigsaw. The wood is also from the trash, by the way. I also drill mounting holes, remove swarf, and grind off the surfaces and check if everything fits. Next, I use the old power cord from the TV set as the cable for the loudspeaker box. But before permanently installing the panels and painting them, I want to make a quick sound test first. So, okay, at least in conjunction with my old test amplifier, the sound quality is good enough for my ears. The music that I'm using in this video is produced by a Swiss composer called Adrian von Zieglers, who allows everyone to use his music, even for monetized YouTube videos, as long as he is credited in the video. With that being done, I spray paint the panels and let them dry overnight. Now we can make the actual test of the car stereo itself. And as you can hear, it basically works. Now I know it sounds pretty terrible here in the video, but that is to a large portion due to the microphone of my camera and not due to the car stereo. The sound quality was actually not all that bad in real life. So if you are a lazy person, you could simply adjust the voltage dividers to an acceptable level and use this as a home stereo as it is by simply using a standard 12-volt AC adapter like this one as a power source. But there is a relatively high level of background noise to be heard. That is due to the very sensitive preamplifier stage. Therefore, I will now take the stereo apart and remove that amplifier stage from the PCB. Before I go for the amplifier, I discover some more burnt out light bulbs that once were used as backlights for the front panel. They too could be replaced by LEDs, but I actually don't want to have that feature, and therefore I simply remove them altogether. And as I said before, a couple of integrated circuits can be found on the bottom side of the PCB. The preamplifiers are easily identified, since they always sit very close to the connector, which leads to the magnetic reader head. The longer the distance of the path to the cassette drive, the lower the sound quality would be. This amplifier is a KA4558, which is basically a standard dual op amp. The dual means that there are two amplifiers in here. One would have been used for the left and one for the right channel. Like in my earlier car stereo hack video, I first shorted out the inputs and totally disconnected the outputs from the circuit by cutting off the paths. But then I decided to remove the integrated circuit entirely by desoldering it. With the chip gone and the output paths cut off, I soldered two wires to the path leading to the audio controller and led them through two holes that I had drilled through a vacant spot on the PCB. I made a new Vero board for the voltage dividers and installed it inside the enclosure. The next step is now to take a cheap Bluetooth receiver and solder two wires to its USB input jack. In this way, it will be possible to supply the receiver from the stereo system's internal power supply. But as of now, the stereo system does neither have a power supply nor an enclosure to even hold one. Therefore, I have to do a bunch of metalworking to fit the car stereo into this old steel enclosure that has been sitting in my lab for a couple of years. Inside that enclosure, we will also fit a linear power supply based on this 12-volt transformer that I salvaged from a broken halogen lamp. But more about that power supply later. I first have to drill, saw and cut some aluminium sheets in order to make a front panel into which the car stereo can be inserted. Then several aluminium pieces have to be worked on to make a base plate that will hold the transformer and power supply circuit. An additional aluminium sheet will act as the back panel, holding RCA jacks, connectors for the loudspeakers, as well as a jack for the power cord and a BNC jack for the antenna. Why BNC? Well, I simply don't have anything better. And with all the metal parts fitted together, it is time to make a simple power supply circuit. This is the power supply circuit that we will use here. It is a simple classic line frequency transformer based power supply. The voltage across the large filter capacitor is going to be around 15 volts DC, and I will simply expect the stereo to be able to handle that voltage, since this is a voltage that a fully charged lead acid battery could also reach. In order to prohibit much higher open circuit voltages though, I have added two load resistors in parallel to the filter capacitor. Via a classic 8705 linear regulator, I have then derived a 5V rail for the Bluetooth receiver. The load resistor of 1 kΩ is supposed to assure proper regulation of the 5V rail at any time. This time I also went for a heatsink. I don't want to use an internal 5V rail for this job, because I don't want to overload the linear regulator inside the car stereo, especially now that we have a comparatively high supply voltage of around 15 volts. I don't think that it would be an elegant solution to use another linear regulator to obtain 12 volts for the car stereo. If I will get problems with the voltage, I will simply remove a few turns from the secondary winding of the transformer. Some of you might wonder if an ATX power supply could be used for this job, since you also get a 12V and a 5V rail from it. That is right. However, I have tried to use older ATX power supplies for audio amplifiers, and I have literally heard that they are too noisy for the job. So all that basically remains is to build the actual circuit on a piece of VeroBoard and connect everything together according to the circuit diagram. This is true not only for the power supply, but for all components of the stereo system. I glued the Bluetooth receiver module into the old cassette slot with its little antenna pointing outward, and after cutting a slot in the back of the old enclosure, the entire unit can be assembled. And here you can have a last look around what I built before I put it all together into the enclosure. The only optical thing that I still want to change is to find a piece of black plastic to cover the old cassette slot, but I couldn't find anything proper yet. Maybe I will also add some stickers to the front panel later. But other than that, the unit is completed and ready for a test.
Bluetooth bearing. Connected.
Germs had been released, and did the germs travel through the air? Or were they coating the ground, or lying invisible on the chain hanging slack from the gate? Or were they eaten?
Ha ha ha.